Welcome to our second meeting here with the North Texas AMS chapter. We're glad to have you here online and in person. So we'll just go ahead and kick it right off with our speaker. It is Dr. Ashton Robinson Cook, who is a forecaster at SPC or WPC, one job ago already. Ashton here was born in Little Rock. His passion for weather started at a very early age, even earlier than most of us. It kicked off at the age of 3 years old when he was, when his home was hit by a likely tornado in Arkansas, and from that it spurred his weather passion along. He has all his degrees in meteorology from Jackson State University and the University of Oklahoma. He's had a number of accomplishments, including the first African American to get his PhD in meteorology at the University of Oklahoma. His work has evolved around tornadoes and then extended forecasts into severe weather, including relations with the ENSO pattern. His work has brought him a lot of accolades, a lot of media attention, and his career began early as a SCEP student, which is now a pathway student at SPC. He worked at SPC as a mesoanalyst and a fire weather forecaster, and now he works at WPC. So he went from severe weather to rainfall and snow. So without further ado, I'd like to introduce my very good friend, Dr. Ashton Robinson Cook. Floor is yours, sir.
Thanks, Steve. I'll go ahead and dive right in. All right. So, I'm in the middle of the presentation. I guess I should start at the front. Apologies. Okay, this is titled My Experiences as a Meteorologist in 2 National Weather Forecasting Centers. And if you guys have questions, feel free to ask. I'd like to make this interactive, but, it's up to you guys as to how interactive you want it to be. But if you have questions, just feel free to ask me. As Steve mentioned, there we go. I had an early encounter in 1986 with a wind damage / possible tornado. But one of the events that also got my interest in weather was from a violent tornado outbreak that occurred in 1997. I used to live at the very tip of that blue arrow. And as you can see there's a rated F4 tornado that moved from Saline County here into Pulaski County and just narrowly missed me to the south. If it had ever occluded to turn left, I might not even be here to give this presentation today. But I was always afraid of storms through my teenage years. I followed them. I, watched the Weather Channel like religiously, just to try to understand how they behaved and watched the local newscasters. But eventually that kind of turned into a passion, and that led to me studying meteorology at Jackson State. This is a close call. Years later, I was able to pull the radar data from this event. It may be a little hard to see, but these are 3 separate frames with 2 panels each, one of velocity signatures from radar and the other from reflectivity signature. And I used to live in the red box on each of these panels. So you can see there's a really powerful signature here over Saline County. This is actually on the ground. It's a violent tornado doing damage at the time. You can see the classic reflectivity structure. Then it just moved to the northeast and just barely missed my place. I had the chance to talk to a Saline County sheriff, who's the county Saline is right just south of where my black box is here. And he said that the storm came up and they didn't have a chance to react. As it turned out, one of his deputies was blown into one ditch. His other deputy sitting right beside him was blown into another. And there was a mailbox with mail from Arkadelphia, Arkansas, which is about 150 miles off to the southwest of the location they were describing, that landed in the street with the mail intact. So this tornado was doing some crazy things, and I just couldn't get enough of tornadoes back when I was younger. And so that really spurred my interest in wind weather. Again, Steve already mentioned I graduated with my bachelor's at Jackson State in 2004 and master's and PhD years after that. And the PhD was a massive achievement. Again, I was the second African-American, the first African-American male to get a PhD from the University of Oklahoma. And there's all my family celebrating. You know, we had a great time. Some of these actually, all of these pictures showed up on the Weather Channel. They did a Black History tribute to recognize me for the achievement that I made by graduating. And then I have a picture there on the upper left of my grandfather. My grandfather was a sharecropper. And so that sharecropping was going on into the 60s and 70s in Arkansas. And it's kind of died out now. But to me, it's just remarkable that I've even been granted the opportunity, not just that, but to actually succeed and have the success story to be part of the legacy for my family. So it's just been a remarkable ride, and there's been its challenges for sure, but I just keep enjoying the day and just keep forecasting and doing what I love. I'm really consider myself blessed to be where I am today. We'll talk a little bit about the Storm Prediction Center. I spent over a decade there. A lot of my student program was there at SPC. So I was there when the building opened in 06. And here's a cool shot. I think Bob Fritchie might have got this picture, but I remember kind of moving things down and the move from the North Campus in Norman down to Norman, the South Norman, where the building was built, and all the challenges behind that. But SPC's mission when I was there was to protect life and property of American people through, you know, issuance of forecast products that deal with tornadoes and other mesoscale weather hazards. Here's an example of a watch. I actually saw tornadoes on this day up in northern Oklahoma, but this was one of the Norman actually was hit on this day. This was back in 2010. But as you can see, this is like a particularly dangerous situation. Most of the people here, I would think, would understand what this means. It's a pretty serious event, but here's an example of a watch. And here's an example of a categorical outlook from 2019. I issued several of those before I left to come to WPC. And then one of the products that I really focused on at SPC, the main product that I issued probably the most frequently was the mesoscale discussions. And they actually have those at WPC. So I'll talk a little bit about those a little later in some of the slides to talk about the differences between the two. And then there's fire weather outlooks. I think fire weather is kind of a little bit underrated. Some of these extreme events, when you start seeing extreme in the categorical outlooks, there can be some gnarly wildfire behavior happening. And imagine, you know, super dry, you know, vegetation with strong winds and a fire front sweeping through a region with, you know, sparks that kind of jump the start of the fires, and it can quickly overtake people. I mean, there's been fatalities as a result of, you know, fast moving fire fronts that were underestimated by people trying to, you know, make last minute preparations to try to preserve life and property at the last minute. So anyway, did a few of those. And then for my dissertation work, at the time, you know, El Nino had been discovered, but the relationship between El Nino and tornado instance was still a bit under debate. And so I worked with, initially with my former director, Joe Schaefer, who unfortunately passed away a few years ago, rest in peace. But then later, with my dissertation committee, we worked together on a paper to kind of describe the influence of El Nino Southern Oscillation on the tornado climatology for tornado outbreaks in the winter and early spring. And I won't go into all of the details on that project, but I will say that in general, for the first 4 months of the year, the El Nino cycle had the greatest influence on synoptic activity, which then in turn influenced tornado activity. If you can imagine, you know, synoptic scale surface lows or large mid-level waves that can open up the Gulf of Mexico and allow for, you know, large-scale warm advection and widespread thunderstorm development. You know, sometimes your tornado outbreaks can really be modulated by just the fact that you have a broad warm sector with air from the Gulf of Mexico well inland, covering a broad area. So it's plenty unstable, and of course there's shear usually in January through April because there's plenty of flow aloft. So, but generally speaking, in each of the three phases of ENSO that I looked at, La Nina was the phase that tended to be most active based on all sorts of, tornado count metrics. We used DPI, we used the number of significant tornadoes, number of violent tornadoes, number of F1 tornadoes, tornado outbreak days per number of months in each ENSO phase. Throughout all the metrics in general, La Nina was the one that gave you the biggest outbreaks. Now, this is a little interesting too, though, because in some of the work that I think might have made it to the dissertation, but maybe not the publication, there was a southward shift in the spring in tornado activity impacting Texas during El Nino. And that's something that was kind of like on the back burner. You know the old saying, the best dissertation is a done dissertation, and these were the meat of my results. And so I went and pushed those out and published them and all that. But Texas was interesting because during El Nino, there tended to be an increase in the spring of tornado activity during El Nino. And I suspect it has to do with the fact that the subtropical jet is still not completely gone from the picture, even though it's, later spring. And so, of course, that time of year, you almost always have moisture. It's just a matter of whether you have flow for dry line or something like that. And so, I don't know, that was a really interesting result. And I bring it up because this year was a strong El Nino, and we had really unusual activity in the southern U.S. And we'll talk a bit about that, time permitting, here today. But anyway, I worked on that. That was a large chunk of my number of years that I spent at SPC was focused on that. But it really got me a lot of publicity, and I'm really grateful, that unique idea was able to kind of manifest the way it did. I was really, really fortunate. But we got publications out of that. And then going back to the mesoscale discussion. So what I basically did for people when I described the job of doing mesoscale discussions, both at SPC and now at WPC, is I tried to keep a very brief template in my mind of how to move quickly through the process of composing a discussion, drawing a graphic, and getting the product disseminated. Now, things might have changed now there, but I know I have some of the same principles that I've carried with me from SPC to WPC when I do mesoscale discussions here. But if you notice, there's three different, and I apologize for how the graphic didn't come out as well here as it had in prior presentations, but there's a blue section, a red section, and in the green section. The blue section kind of represents what's happening now. What are the current trends? The red section represents what's happening in the environment to support the current trends and what type of severe weather hazard might result, whether it be just hail only or hail and tornadoes, hail, tornadoes, and wind, maybe wind gusts only if you're missing low level shear. All of those environmental ingredients, you just I would kind of keep a note of them as I'm moving through the process of maintaining Weather Watch, and then have that ready to compose in the discussion as needed. And then for the green section, I actually offer a forecast, and I think it's important, at least I felt like it was important in my time at SPC, but even more so at WPC now, that we offer a forecast in our mesoscale discussions, because oftentimes we're dealing with mesoscale hazards, and there's been a number of instances where the high-res models, as good as they are and as big of a breakthrough as that's been in weather forecasting, they still struggle with cold pool formation. And that's just a challenging aspect of the forecast that me, over the years of my forecasting of mesoscale discussion or mesoscale phenomenon, thunderstorms mainly, I understand that the models have those biases, they have those weaknesses, but I can look at the information, I can look at meso-analyses in real time, can look at and analyze things and make my own forecast and then offer that forecast. So it's important, as we're making forecasts, to remember that we're humans. If we can't beat the models with regularity, then what's the point of having a human as a forecaster? So I try to keep that in mind, and I always try to keep that um, at the forefront when I'm doing these to make sure that I'm offering value beyond just stating what's happening or stating that the models or the HREF or the HER or some or the NAM is saying this. It's a little bit more involved than just that. But when I was at SPC, we did tie these into convective outlooks, mainly for consistency of messaging. And that's relevant for a lot of cases, but one of the things I noticed too is that when things were not necessarily going in the way the convective outlook was describing, a mesoscale discussion could be really important for highlighting those short-term trends. So, but the other thing at SBC, everybody knows, the big days, the high-risk days, the moderate-risk days, the big derechos, the big tornado outbreaks. Everybody remembers those, but one of the things I learned from working ops at SBC is that every day is not an outbreak. And there's a lot of times when there's just, normal run of the mill thunderstorms that go up in the summertime, especially, and they produce damage. They knock trees down. Sometimes those trees fall on homes or have an impact, knock power out, things like that. And we have responsibility for that. So the job can get kind of challenging, I think, in that way too, because in the summer it can be, susceptible to burnout, things like that. Um, I've even seen that at WPC too. But it's also really straightforward. And again, the models can give you an idea, but sometimes if you just trust the models blindly, you'll go astray. It's just the nature of the job at this point. Of course, the models are improving all the time. And then here's a picture. I saw a lot of tornadoes when I lived in Oklahoma, especially starting in 2010-ish, I think was when I started really seeing a lot of really big stuff. And at the time this tornado moved through, I lived about 7 miles or 7 minutes on the line south of the track. And I lived due south of one of the schools that got hit on the west side of Norman. And this was traumatic. I didn't get any video this day because I was just too concerned about warning people. And it was just at the wrong place. If this was out in the middle of nowhere, I could just enjoy it peacefully. But because it was where it was with, friends and family near the path, it was just a little too much to try to enjoy. But moving forward, storm chasing was a big hobby and a big deal. And I see I'm at 123 with only 7 minutes left for this talk. So I do have a couple of videos, but what I may do is share the slides and let Steve maybe circulate the videos that I wanted to share. But Steve,
You're good, man. You can keep going.
Okay, cool. Well, Steve, you actually may recognize the picture there in the lower right. It's one of my favorites, Penny Chase. I mean, I'm sure you see you're actually taking a picture, and I'm taking a picture of you taking a picture of the tornado. But that was Dodge City in May 2016. Each of these cells were actually tornadic, but a few of them are really well visible. I mean, you can see like the structure of updrafts. I've got time lapse from the upper two photos. I mean, just incredible stuff. And then actually, given the fact that I'm talking to an audience in Fort Worth, this was the last, I believe this might have been in 2015, the last significant tornado to move through, unless I'm missing one or two. The last, it was a F4 that went through Garland. This was the parent supercell that actually did that. Now, I don't advocate chasing at night. This just kind of happened that way, but I found a way with some contact with some people remotely to kind of help me navigate the storm. But I found a way to kind of follow the storm off to the north, but at a safe enough distance that I could stay away from any not only mesocyclone, but also a secondary tornado that actually ended up doing significant damage, forming east of the initial mesocyclone that had produced the F4 over Garland. So it was kind of cool to see that type of atmospheric power in real time, and to just be in the inflow of some of these storms is just magical. But it's been some cool experiences in there. Okay, I'll try to move quickly through these slides. But this is the Weather Prediction Center overview, hosted by yours truly. And what the Weather Prediction Center is a bigger center than WPC because there's more hazards. There's temperature, there's precipitation, which is a big focus. We do key messages for any type of tropical activity that makes landfall. We're actually a backup to the Hurricane Center. And we also have a desk or several desks that contribute just to surface weather map analysis and hazards, not just for the country, but also the lower 48, the CONUS, but also for Alaska. So there's a lot of responsibilities here, but it's almost always something to do, except for today when there's no precip hardly across the country. I'm in the rainfall hazards part of WPC, and with my expertise as a mesoscale forecaster at WPC, I slid right in as a mesoscale forecaster here at WPC. So WPC does rainfall and also snow and ice going out to the next 7 days. QPF, that's typically a job for the lead forecaster. I'm really grateful to my management here that I've been able to serve as a lead on a temporary basis from time to time. Actually did that just yesterday. But it's been cool to kind of put this product together. But we do forecast for QPF every 6 hours going out through 7 days. We also have a couple of products kind of centered around excessive rainfall. There's the PQPF, the Extreme Precipitation Monitor, the excessive rainfall outlooks, and the mesoscale discussions. I do mostly mesoscale discussions, but I'm trained to do the QPF and the ERO also. Now, again, there's MPD, there are MDs or MCDs at SPC. Those are the mesoscale convective discussions. There's MPDs here at WPC that describe mesoscale precipitation trends. Okay, so they're a little bit different. The biggest thing that well, there's a couple of really big differences in what I used to do for SPC and what I do here now at this desk. The one is as for precipitation. So there doesn't necessarily have to be a severe component in order for there to be flooding. Normally, if there's like a series of training storms or there's an area that's getting repeat rainfall over several hours, that would kind of trigger, that I would need to issue a forecast for that. Ideally, a forecast to get out ahead of something like that happening. So that's what we try to do. There's also been some really extreme events lately that have happened where we've gotten 10 inches of rain in 5 hours in certain spots in the southern U.S. And those are really hard to pick out, but when you do, you get out ahead of it and you hit it hard. One of the things with MPDs is that it is a messaging tool for people to use to kind of help understand convective trends and what the impacts might be in specific locations. But the structure is generally the same, actually. I still talk about what's currently happening, what the current trends are, how are storms behaving, what environmental factors are there supporting the ongoing flash flood scenario, how much precipitable water is present, how much instability, is there a low-level jet around to kind of help focus storms along a corridor so you can get repeating and training. And then again, what will happen? It's important to have a forecast component to this so that people understand, your forecast may actually differ from what a lot of the models are saying. Mesoscale forecasting can be hard and is relatively unpredictable compared to some of the other things we try to forecast for. So having that expertise and being able to convey it is really important. The other thing too, I almost forgot. One other aspect of the forecast here is that we take into account, I use flash flood guidance. Sometimes we use soil moisture, but we do take into account the hydrology to an extent. And we look at what areas are susceptible to flash flooding. Like in the West, the soils are really rocky. There's, low spots and canyons that can help with runoff. And so 1 inch of rain out in the West in an hour is a big deal, depending on where that falls. Whereas one inch of rain in an hour in Florida is nothing because they get that all the time in the summer. It would take more of like maybe a tropical system making landfall to get the extreme flash flooding that you get in Florida compared to other parts of the South, like maybe Arkansas or the foothills of the Appalachians or even out West. Okay, and then this is the last part of my presentation, and then I have a few more slides if people are interested. But essentially, I took on a project right when I got here. And part of the reason was because I was very familiar with SPC's mesoscale discussions. I had gotten pretty quickly familiar with WPC's mesoscale discussions, but I noticed that they had the excessive rainfall outlooks, and I wanted to find a way to look back at what types of forecasts or categories were issued in certain environments, and then also to kind of help me get kind of spun up on, what does it take to get a high risk, or what does it take to get a moderate risk. Around the time that this idea was conceived, Hurricane Ida was making landfall, and there were questions because Ida actually hit New Orleans and Louisiana, Mississippi, and then curved into the Northeast and caused huge problems for flash flooding from Pennsylvania through New York City and southern New England. And there were people asking questions, this is a large high risk. Is that the biggest high risk we've ever had? How often does Connecticut get a high risk in the ERO? And so essentially what I did was I used a few scripting tools that I've kind of developed, dating all the way back to my dissertation, and built a ERO climatology and a web home for flash flood statistics. And so essentially what this means is that there's now lists of high, moderate, and slight risks by slight risk days by state, CWA, and metro area. And this is evolving because what I'm finding out is that people are using the information. One of the more interesting use cases I've gotten recently from this information is I had a statistician for FEMA asking me for help to kind of mine the information to figure out how to predict how many people would request disaster assistance after a big flood. Just fascinating stuff. But the website is there. There's ways to email us if you got questions about it. And then I'll just kind of flip through just a few results. But essentially here, we have a busy season, just like probably every center in the country. And that busy season is decidedly summer. One of the things that I didn't mention about the MPDs is that usually there's one or two people at any given time doing mesoscale discussions, but most of the time it's just one person with that responsibility. So we can imagine, watching, the entire CONUS for flash flood potential. That can be really challenging. It requires you to move quickly through the process of assessing the environment, figuring out, how things are going to evolve, and then conveying that information into a product to actually go out with a graphic to go out to the public and to forecasters. You notice here also with the EROs, there's a tendency for almost every day in July has a slight. Almost every day there's a slight in the ERO somewhere in the CONUS. But we have a peak in the moderates and especially the highs in October and August and September. That's tied to tropical cyclone landfalls. Those are one of the biggest drivers of higher end highlights in the ERO. And they, naturally also have, some of the higher impacts as well. From high risks, from this standpoint, there's certain FOs that are kind of like hotspots for high risk, Lake Charles being number one on the list. The reason why this is the case really is because of Harvey. Harvey was a very large, slow-moving, and intense storm, and there were several days of high risks. And keep in mind that this chart is actually counting up the number of days in each, the number of the separate days for each CWA to have a high risk. And it could be any part of the CWA that would have a high risk. So Harvey, with it being slow-moving and then, meandering over Texas and eventually moving up into Tennessee, I think there are about 7 different days of high risks in some part of that area. But there are also some other landfalls that prompted high risks as well. Interestingly enough, Los Angeles, Oxnard, they get a lot of high risks. We're responsible for forecasting atmospheric rivers, and sometimes those can create really big impacts in that part of California. And sometimes we have to go with high risks just for that. We had a tropical system in the southwestern U.S. today. So when this is updated, there'll probably be some other areas in here that have highs as well. No, Death Valley had its first high risk ever, but we were actually able to mine that information based on what I put together on the website. So kind of happy about that accomplishment, and also excited about the messaging that we could the messaging potential we could use based on this information as well. The other thing too that I noticed and derived from the work is that high risks are actually becoming more precise. There's a lot of speculation as to why this is the case, but we think that the improvements in numerical weather prediction models, and particularly the high-res models, and improving our understanding of extreme events like these can actually help kind of focus the areas of spatial extent of high risks. There's also year-to-year fluctuations in this as well. So here's a list of high risks, basically kind of showing like which ones were the largest. Actually, the largest high risk actually happened in 2018 in a cool season event in February. But a lot of these, you notice, are tied to tropical systems like Irma, Florence, Harvey, of course, Michael. And then, of course, Ida was a huge deal, but I don't think Ida's size, the size of the high with Ida, cracked the top 10. So, all right, there's more information available. I'm easy to find. You can email me or reach out to Steve to have Steve ask me the questions, or you can ask them here. And I'll stop there with this beautiful picture of a tornado that was in the process of hitting Chickasha, Oklahoma at the time. But yeah, I'll just stop here. And if anyone has questions, feel free to ask me now.
Cool, Ashton, thank you so much. All right, let's open the floor up to questions. If anyone online or here in the room.
I've got one.
Okay, go ahead, Scott.
Yeah, I'm just curious, and this may get kind of into your personal kind of interest level, but is there, outside of hurricanes coming on shore, is there a particular kind of scenario meteorologically that you look for specifically that really, you jump on that and you say that is really going to be a problem and it's maybe kind of unique? Is there something like that maybe that you see and think about?
Goodness. I'm kind of glad you asked this question. I'll share my screen again.
Okay.
I had this as a backup, but given the fact that we're low on time, I was going to maybe pass it. But now that you mention it, have a look at this radar image. And I showed it because it's such a unique, this is helping to describe such a very unique scenario that unfolded over the Mobile, Alabama area. This MCS, despite the fact that there was northwesterly flow aloft, this MCS actually backbuilt into New Orleans and the north side of Lake Pontchartrain as well. There was about 10 inches of rain or so south of Mobile that prompted flash flood emergencies down in the area. But it was interesting. There was a little bit of uncertainty as to how this might evolve, but once we kind of started seeing that there were like these embedded mesos that were establishing a gust front, with the gust front being reinforced by the heavier rainfall and actually propagating westward. I mean, it was just such a fascinating event. And what I've noticed working this desk is that there's been a handful of these cases, usually in the warm season, where we get some sort of convective complex in an extremely moist and buoyant environment. In this particular case, I think the Capes were somewhere around 5,000. Mid-level lapse rates were extremely high at about 7, which is really high for this part of the country in June. And they just exhibit this behavior that's just atypical. But they grow upscale and they just kind of propagate, and it's based on internal storm dynamics almost more than just the ambient flow aloft and the steering flow. So this in a way, this is like a real test of understanding of mesoscale meteorology and applying all those principles all at one time to try to get a good forecast out. And but I was actually able to do that. And let's see. So this is the product that I actually issued in advance of the worst of the flooding. But basically, I used this to kind of basically try to highlight that, hey, this is a pretty serious problem. And because I went back toward the Mississippi River here, there's some indication or implication that there was going to be some type of westward shift with the heavier rainfall. So I hope that answers your question, but it's these types of events are crazy and they're atypical. It's not something you'll find in a textbook. A classic supercell that evolves all by itself with all the shear and stability it produces a tornado. Like that happens, but more often you actually get these really complicated scenarios where you get back building, and it's uncertain whether it's going to continue back building. But if it does, there's going to be a big problem because there's population impacts, there's heavy rainfall, there's, in this particular case, there's 5,000 Cape, 1.8-inch PW values. So yeah, this is this is mesoscale meteorology in a nutshell right here.
Yeah.
But I did that answer your question, or I kind of rambled? I feel like.
No, that's a good example. So how did the short-term models do? Were they struggling with this?
At some point, I mean, maybe I'm a little old school here, but at some point, I don't even pay attention to what the models are saying sometimes.
Yeah.
Sometimes you just have to rely on observations and what you know about the weather and how things are evolving with the convective complex, and just make a forecast that way. So in this particular case, I don't remember using the models because the models didn't really handle there were embedded mesos that actually forced the cold pool to form within this. And I don't have the velocities to show it now, but that's kind of what was happening. But because there was a cold pool forming, that cold pool was shifting back to the southwest. Meanwhile, you had a pool of 5,000 Cape back in here with 1.8-inch PW values back in Mississippi. And so with that type of convergence, you're forcing parcels up that can just kind of rise freely once they get past a certain level. So it's easy to get convection reforming back to the west. And so that was kind of the basis for the forecast, and also the heightened wording, the significant wording.
That's great. Very dynamic. I appreciate that.
I was going to ask about what were some of the tougher days to forecast, and obviously this seems like one of them. So I'm going to ask this one. What were some of the forecasts that you were proud of, either at SBC or WPC?
Well, I'm going to give a shout to Steve Kerfetti on this one. I was a relatively junior forecast, and this was the first day, I think, that I was a junior forecaster, rather, and it was my first day forecasting in an event where there were tornadoes threatening Norman. And we actually had a tornado at Lake Thunderbird a week when we also had big tornadoes down in southern Oklahoma, like some big, I think Katy, Oklahoma was one of the towns that had a near hit. Roth. There was an outflow boundary down there. Storms were just going crazy on it, big instability. But then, so I came in, and within the first hour, we noticed there were tornadoes in Nebraska that weren't covered by a mesoscale discussion. And so Steve, what I appreciate about Steve was that there was no panic. There was just calm. And Steve and I were just talking about the weather, and he was the lead forecaster, and his calm and his presence really kind of helped steer the ship in terms of getting the products to cover the evolving threats and actually kind of catch up. So that brings me to this point. Sometimes the most stressful part of this job and the most stressful part of what I've experienced at SBC was when we were behind. If we were behind, things were evolving and we're struggling to kind of catch up, that's when things got really stressful. And so there was and of course there's a meso over the building. I mean, we're in a tornado watch, we're in the warnings and all this kind of stuff, and people are flying in and out of ops trying to look at the meso sitting over top of us while we're trying to get all this stuff covered. But Steve had a really calming presence, and I'll never forget that. And that's one of the things about being a lead forecaster, is that you have to have calm in the middle of stress sometimes in order to really keep things on track. But that was the first 2 hours of that shift. And I want to say that was in 2016 when that happened. We were kind of catching up a little bit and maintaining situational awareness of what was happening in southern Oklahoma with the real high impact stuff. But once we got past those first couple of hours and things were caught up, the watches were all out, the mesoscale discussions were out, then we could just kind of go back into like, normal routine, normal routine weather watch pretty much. And because at SBC and kind of to an extent here at WPC, because we do weather watch all the time, most days are not super hard to keep up with. But it's the days where, there's other circumstances or maybe things are happening that you didn't necessarily expect. That's when the job gets kind of stressful, I've noticed.
Cool. Well, I'll ask one last question before we wrap up with chapter business. So given everything you said about ENSO and how it influences tornadic activity over Texas. So given what you said, it sounds like we're going to have a fun spring here next year, right?
Perhaps, but I'm kind of the belief now that there's more to it than just ENSO. So that's one player, but we've always known that with seasonal forecasting, there's more factors that go into play than just ENSO. ENSO is just one of the bigger drivers.
Okay.
And it's also kind of straightforward too, in ENSO, the subtropical jet is strong and displaced to the south. And in La Nina, the jets are a little bit, the subtropical jet's a little weaker, but the northern stream is a whole lot more variable. And your weather can kind of fluctuate based on that. But there's other factors as well, and that's an area of evolving research too. So,
okay, I wonder if it was locally based, or if like Matt and Julian or in the North Atlantic decadal had an influence in there as well. But yeah, I guess we will see what happens here.
Yep,
cool.
We shall see.
Ashton, thank you so much, and yes, good times looking at those pictures from Dodge City and Wellston, the other ones.
Yeah. That was some good times.
Those are fun days. So what I'll do is I will text you later. I will get your address and we will send you an Amazon gift cards to
great.
A speaker for us. I know a couple of our officers have been out. They have doctor's appointments. So Dave, I don't know if you have any chapter business on your end. Okay. All I mention is dues. Just mail him to Stanley or see him next time he's here with us. The next meeting is scheduled for Tuesday, November 14th. It'll be held at the North Central Texas Council Government Building. So that is right near Six Flags in Arlington. Our speaker is still TBD, and I am working on that, and I'll get one lined up soon here. Does anyone else have any questions or comments? Or
thank you everyone for attending.
Yeah, thank you so much. Meeting adjourned. We'll see you all next time.
Thanks for having me, everybody.